Hello everyone. So today we will start with our next set of operators. We discussed arithmetic operators previous day and we discussed relational operators. Now Python comes up with number of operators like logical operators, bitwise operators, some operators which are unique to Python. Now let's see how we can work with logical operators. When we talk about logical operators, these are generally used to join two expressions or they are used to join two operands, and based on the type of operator we are using, they gives result in the form of boolean value, that is either true or false. So if we are using logical operators, we have three of them. One is AND operator, another is OR, and the last is logical NOT. Now how these AND, OR and NOT operator works? AND operator works or gives you a result true when both the conditions are true. Means if an expression or if two expressions are joined together using AND operator, both condition needs to be true or valid in order to be in order the result to be true. For example, let's say we have an expression. I had a variable true a which is been assigned a value true and a variable b which is assigned a value false. When I'll write print a and b, it will display the result as false, which tells that both of the condition needs to be true. And let's say if I'll write this and I'll run the code, it will say true because both the conditions are true. Now, what is the purpose of OR operator? When I'm using logical OR, either of the condition, if it is true, then the result will be true. For example, if I'll run this code, it says true for the second value. Now see, A is true, B is false. So one is true, another is false, or checks for the validity or gives an output true if any of the operand on any of the side, on either of the side is true. Now not means it negates the result. Negates means if the value is true, it will change it to false. If it is false, it will change it to true. So here the value of A is true. If I'll write not A, it will print false. So this is how we can use logical operators in Python. Now, next are the bitwise operators. Bitwise operators bitwise AND, comprises of bitwise OR. Then we have complement, then XOR. Then we have shift operators. These shift operators are shift right and shift left. So we have shift right and shift left operators, which works as or which works to shift the bits. Now, how bitwise operators work? Whenever we are using bitwise operators, they work on the binary value of a number. Now, let's say if I'll write A as 2, B as 3, the binary equivalent of 2 is 1, 0, and the binary equivalent of 3 is 1, 1. So, when I'll write A and B, I'll execute this code. Now it is logical AND. Logical AND means if both the values are true, then it will give you a true result. Again, it sounds similar to the logical AND operator, but it works on bits. So here in this case, if I'll write 1, 0 and 1, 1, 0, 1 will give you 0. The result will be 0 for this. And 1, 1 will give you the result as 1. So the result will be 1, 0, which is equivalent to 2. Or works with either or. Either or means if one of the value or both of the values are 1, then it will give you 1. So in this case, 0, 1 will give you 1 and 1, 1 will also give you 1. So the result will be 3. Now if I'll write complement A will complement the value of A. Now in this case, let's say if I am using this, it works on the principle of how much the word length is. So it will complement the entire value. And now if I am writing 2, let's say if it is an 8-bit value, it will be stored like this in the memory in the form of 8-bit pattern. So when I'll write not A or complement A, it will complement all the bits, and that is why the sign will also change based on this. And I hope you probably had learned how the signs work. Like we have sign magnitude representation, we have two's complement method, we have one's complement method to represent a bit in negative or positive. So it works on the same principle. That is why the sign has been changed here. Then we have XOR. XOR works on the pattern like this. It works on complement A or B A dot B plus A dot complement B. This is the equation for XOR. Now this dot represents a AND operator and this plus represent OR operation, logical operation. And this complement, as we already had discussed, it will complement the bit. Now let's say if I'll write A XOR B, it means either of the bit needs to be 1 in order to have the value as 1. If both the values or both the bits are same, then the result will be 0. So in this case, the value here is 1 0. We will assume 1 0 and 1 1. So let's say if I'll write 0 1, the result will be 1. And for 1 1, the result will be 0. And it is equivalent to 1. So that is why the result is 1 here. Now if I'll write A shift 2 bits. Now this is right shift, means I want to shift the bits to the right. Now right means if I'll write 2, that means this bit will move 2 places ahead. Now there is no bit or there is no block ahead of it, so these bits will be discarded and the new bit pattern which will be formed is all 0. So that is why the result is 0. Now if I'll shift left, left shift means if I'll write A left shift 2, that means shift 2 bit places left. So the new bit pattern which will be formed is 1 0 0 0. Both these bits will be shifted to 2 places ahead and then it will form this bit combination which is equal to 8. So the new bit pattern is this and the decimal equivalent of this will be 8. So this is how bitwise operators work. Now, when we are working with Python, we have some shorthand assignment operators, and these shorthand assignment operators will help us to assign the value based on, uh, say, let's say, for example, if I'll write a equals to 10, I want the value to be changed, or I want to reference the value. For example, let's say if I want to work with, I'll do this. If I'll execute the code, I'll write A and I'll write A plus equal to 10. Then I'll print, first I'll print A over here. Then I'll print after adding, I'll write here. Then I'll subtract some value from A, let's say 2. Then I'll print this value again. I'll write A multiply equals to 10 and I'll print the value of A. Now these are shorthand assignment operators. Now how this will work? Let me execute the code. A minus equal to Okay. I let the bracket here so it shows an error. Now it says for the very first print statement, it says 10. Now, when I'll write a plus equal to 10, it is equivalent to a equals to a plus 10. So it will add 10 to the number, it will give you the result as 20. So I printed this value. Similarly, if I'll write a minus equal to 2, it will give you the result as a equals to a minus 2. Now this means 20 minus 2, which is 18. Now I already had 18. If I'll write a multiply equals to 10, it will display a equals to a multiply 10. That means 18 multiply 10, which is 180. So this is how your assignment operators work. This is normal assignment operator. These are shorthand operators which works or which adds or multiply the values like this. So this is how we will use uh, these operators in Python. Now, apart from that, we have operators which specifically are used when we want to work with Python objects. For example, we have operators which are called membership operators, and we have operators which are called identity operators. For example, let's say I want to work with the uh, Python operators which are identity and which are membership operators. Let me show you how we can use them. Now, if I want to work with these operators, these are the operators which are used to check whether a given element is a type of another element or not. For example, uh, let me show you the code. Let me find the code for you. Now, when I am working with these operators, which are membership and which are relationship operators, we need to know that these two operators work on the concept of whether a given element belongs or is a part of another element or not, or whether there when we have a sequence or list, whether a given value is a part of a sequence or a part of a list or not. So let's see how we can work with Python identity operators. Now we have two operators which are called identity operators. These are is and is not. Now how these two operators work? For example, let's say I have an object x which is equal to a list value. We'll learn these data types in our later classes. So I declared a Python list with the name x. I declared another which has the same content as of x. Then I had written v equals to x. Now when I'm doing this, I am actually passing the reference of one object to another. That means both of this object will be working on the same reference ID. That means these two objects will belong to the same memory location. So if two objects belong to same memory location, then identity operator will return true, and if they are not, then it will return false. So if I'll write print x is z, that means both belong to same memory location. If I'll run the code, it says true because both are assigned or are being referenced using same location. Now if I'll write x is not y, it will also return true because x and y, though they have same values, they do not belong to the same memory location. Now see, this is and is not is different from double equals to operator. Double equal to operator checks for value. For example, if I'll write print x equals to y, When I'll run the code, it says true. Means x is equal to y, but x and y does not belong to same location. So if I'll write x is y, it will give you the result as false because they both belong to different memory reference, though the values are same. So equals to operator checks for value, is checks for whether they belong to same location or not. So this is how we will use Python to check whether two variables or objects belong to the same reference ID or not. So these are identity operators, which are is and is not. So not checks for whether both are not at the same reference. So if they are not at the same reference, it will result in true. Now, membership operator checks for whether a given element is present in a sequence or not, or whether an object is a part of a given sequence or not. Now, again, the values, the objects which we have are is, in and not in. So let's say I declared a list and I want to check whether a given element or object belongs to this or not, this list or not. I'll write print, or I'll simply write object name or value in my object or in my sequence. So it will return true because CD is a member of X. And if I'll write not in, it checks for whether an element does not exist in a given sequence. So in both the cases, the result will be true if I'll run this code, right? So it says true. Now if I'll write X, Y in X, when I'll execute this, it will say false. That means XY does not exist in X. So that is why in will give you a false result. So this is how we will use identity and membership operators. Identity means ID or reference to the same memory location, and membership means whether a given element or object or a given value is present in a sequence or not. So these are the operators which Python has, which we use often in our code. Now in the next class, we will be learning different control statements, like one which can be used for decision making, for purpose like iterations and so on. So in next video, we will be learning statements which are called control statements in Python. Thank you.